Proszę Państwa, w tej chwili poproszę pana Aleksandra Boricia, który jest pracownikiem Agencji Regulacji Komunikacji Elektronicznej i Poczty w Serbii i przedstawi nam informacje o pomiarach i monitoringu radiowych pól elektromagnetycznych w jego kraju.
Tech support is not with us. Okay, here it is.
Right.
Yeah, we're fine. Yeah, sure. Thank you. Hello. Good day to all. And first, I would like to thank the organizer for the invitation and for the chance to speak at the conference. Today, I will speak about the EMF monitoring system in Serbia. First part of the presentation will cover the technical part of the system, and the second, the reasoning why we opted to implement such a system. When fully implemented system will have 100 EMF sensors in 25 cities throughout Serbia. The locations itself will be increased sensitivity locations, which means kindergartens, schools, and hospitals. We are at the first phase of the system opted for one vendor, but now we are implementing the second one. The reason is that we wanted to avoid vendor lock so that we have a freedom to buy competitively from several vendors. Also, we have the possibility to implement 3 more vendors to our system. That's the terms of our contract with the developer of the portal. The project is open, meaning that the third parties can also join the project if they are willing to buy the probes. We will integrate them into our system, and then they can publish the results of the measurements as well with our own sensors. Project phases, obviously, we first started with the location acquisition. We did the measurement with the handheld instruments, and we tried to find the locations where the exposure levels are higher than 1 volts per meter. Reasoning being that if the level is lower, we feel that there is no sense in measuring at those locations. Additionally, probes are obviously are tested at the vendor premises, but we did our own testing to be sure that they are measuring in the right and the correct way. We configured them for the first vendor, Narda. We opted for a 3G modem to communicate with our central location. This was the first time that Narda implemented such a sensor, such a modem. Previously, they used 2G modem, and initially we have some issues with that, but they did some software changes, and now the system is working correctly. This was quite a challenge for a few months. Initially, you will later see from the presentation from my colleague from Hungary, they opted for a nomadic sort of measurement. We are doing fixed measurements on the locations that are not that are stationary. We not move the sensors at all. We have electric current power source, and in addition we have a solar power, but this is not a primary source. This is just a backup system, so that probes are working all the time, even where there is a outage from the electric grid. And finally, obviously, we installed the systems in many locations. This is just a picture of one of them. As I mentioned, we are now implementing Narda wave control. These are non-selective probes. They are fairly similar. They all communicate with the system throughout mobile network. There are obviously alternative systems of communication, but but using mobile network is probably the most efficient one. Probes are slightly different in terms of the highest frequency they can measure, but to be quite honest, beyond 6 gigahertz, it doesn't really make a significant difference at this point. After the 5G mobile networks are implemented, that will be a different story. This is one location where we are implementing selective probe. This probe is significantly bigger and harder to install. As I mentioned, the probe also has a solar and the electrical power source, and it has also an ability to measure 20 subbands. We find this location to be interesting. It is in the center of the city, in the elementary, on the roof of the elementary school, and there are a lot of systems, radio systems around it. And if you can see it on the right side of the slide, the primary source of the measurement is 4.76 volts per meter, and it's a radio broadcasting system that can also be seen, if I'm not mistaken, in the picture just above the probe, the mast in red and white. It also shown that the impact of the base stations, which are many around the location, which is because it is the center of the city, is not contributing as much as we would expected. In addition, you can also see the picture you are seeing is the same picture that the end user can publicly view throughout the web portal. The user can choose the period of time they want to observe, and they can also see the location itself, the panoramic view, and the several pictures describing the location in details. As I mentioned, this is the location. Marked in red is the elementary school I previously mentioned, and what the probe is measuring is 39 radio systems in 11 separate locations. This location shown here is in the student dormitory, also in Belgrade, and this is the highest value, average value that we ever measured. It's not all that high, and to be quite honest, we didn't expect it to be much higher than this. That was not the reason why we implemented the system. The main reason is that we wanted to show the public what we already previously known, that the exposure levels are not that high. But it's, as you all know, it's very, very hard to persuade the public that that is the fact. This is, again, a non-selective probe, and on the graph you can also see the red line showing the lowest limit, the lowest threshold, sorry, prescribed in our legal framework. The system itself, the way it communicates, obviously there is a EMF source, there are sensors which communicate with the central server once a day throughout mobile network. The probes measure in 6 minutes increments, and every measuring result can be seen on a portal. A portal has a public part where every result and every location is shown, and in addition we obviously have an admin part which gives us the ability to add different locations, new locations, or to move a probe from one location to the other, which is very, very rare, just for the location that turns out to be with the really, really low level of exposure. And now maybe at least for me, the more interesting part, that is why we implemented the system. So as Dr. Oli already mentioned, we knew that the levels are not very high, but the public was not persuaded. You can issue a public statement saying everything is okay, but when you talk to end users, which we do, they always tell us or write us or call us and saying, okay, I have a base station, it's near my flat, I don't want it there, will I get ill, what will happen to me? That's why we implemented the system, and we feel that was the right move, especially with the advancement of 4G Advanced and 4G Advanced Pro, and at the end 5G, because to be honest, a lot of these terms you're seeing on the screen are being mentioned today, and the telecom industry is really not helping because they are using terms like massive MIMO, active antennas, beamforming, and to us, which have the idea what it is, we know it's nothing to be scared of, but the end user have the perception that some beam will watch him, will follow him in a massive and active way, and so the fear is elevated without any base, without any true base. Plus, as the 5G is approaching, also the millimeter wave bands will be implemented, and it will be very hard, at least in my opinion, to explain the end user why you are using 28 gigahertz for the last mile, which is the technology they are probably think that will harm them, which is really not based in reality, because when you do 28 gigahertz as a use as a last mile, you will hear terms like leaf and branch attenuation, which means that these powers are so low that if you have a tree between you and your apartment and the base stations, even the leaves and branches from the trees can add additional attenuation to the power of the signal. So it's everything but not harmful, but harmful, sorry. Regarding the limits of exposure in Serbia, we have rather strict limits, not as strict as Switzerland, Poland, and Italy, but our limits are 2.5 times more stricter than ICNIRP. Still, we are lucky that we will be able to implement 5G without any significant obstacles. In comparison to what was being said before, at 900 megahertz, our limit is 16.5, which is more than enough to implement 5G rollout without any obstacles. And now something about operator obligations and obstacles they have. On one side, you have the public saying, okay, it looks like a Wild West. The operator can put the base stations wherever they want, but that is so far from the reality. Every operator has a vast number of obligations they have to fulfill. In Serbia, they have to do mandatory public consultations, meaning they have to publicize in the local newspapers that the new base stations will be implemented on the certain locations. They have to do pre and post measurements to those locations to see the impact that the base stations in question will have on the environment. And if that limit is more than 10% of the prescribed limit, they have to do those measurements every 2 years. So it's very time consuming. It costs a lot of money. It's very expensive, like I said. And on the other side, the public thinks that it's like no regulation whatsoever. So that was the main reason why we implemented the system. We wanted to show the public they have nothing to fear about, that the government, the Ministry of Environmental Protection, and the regulatory agency are doing their job, and the levels are within the prescribed limits. So at the portal, the end user can see the results, but can also have an educational part of the portal where can see what the EMF is, what the levels are, and what the levels, obviously, at the real time of the measurement locations are. And we are certain, and we know from talking to end users, that this actually gives results. Like I said, measurements are public, but at the second phase of the implementation, we used a slightly different tactic. We called the municipalities and asked them to choose the location themselves within the margins, the technical margins that the project prescribed. So not only that they are picking the locations, they are also involved in the measurements in terms that they are present and they can see the first the measurements that are done in the first phase with the handheld devices. And the effect is that when they see that the levels are really low, first they are surprised, then they are relieved. And what we are trying and successfully achieving, they are sharing those results and with the end users, with their neighbors. And the number of complaints we are getting is getting lower, because if they are themselves can see that there is nothing to be concerned about, then also their neighbors are sharing the same effect. Additionally, we are doing several phases of PR campaigning. We had TV appearances. We had the printed media text published both in printed and electronic publications. And now we are in few weeks starting the social media campaigns, trying to get even more users to see the web portal, to see the results, and to get acquainted with them. As I mentioned, project is open, so anybody can join if they are willing to spend some funds of buying the probes. Municipalities are still thinking about it. It's not that lot of money, but it's a time-consuming process. They have to do tender procedures, and we will see if that will give some effects. If not, the agency itself will fund the project until the end. And the last slide, as we toured the country in trying to find the suitable locations, we came to the conclusions that a lot of them, like 9 out of 10, are not suitable in terms that the limits we are measuring are below 1 volts per meter. So now we are implementing the prediction software that we already have. The agency already have, but we used it for broadcasting system, from radio and TV broadcasting systems. Now we are importing the data from the mobile operators for the base stations, and we will do the prediction of the EMF levels with this software, and in that way optimizing the number of locations we are physically going to visit, because using the system you can fairly accurately, again, it is a prediction software, the values are predicted, not true measured values, but we will be more efficient in choosing the location, and will really save a lot of time, money, and effort in this process. Thank you.